Hi, 515 students. Uh, Today we're going to be talking about two-factor analysis of variance from chapter 14. And the 2 by 2 ANOVA, or 2 by 2 factorial, is a terrific design. It is just a wonderful design and has lots of relevancy in uh, many different fields, but specifically you can test main effects, interactions, simple effects, and you can just do a lot of testing and a lot of inquiry in data sets using the factorial study. So in exercise in chapter 14, the exercise we have for that says enter the below data into SPSS. Conduct a two-factor analysis of variance to see if there is a difference between any of the means for the different factors. Write up your result in APA format. Use type 1 error rate of 0.05 to evaluate each main effect test, factor A, factor B, and we'll do the interaction as well. Um, so I'm drawing from the example in the text on page 478, table 14.5. Okay, and there seems to be a little bit of a problem in the text far as the data. It says the number of observations is 30. But if you look down here, like in the table right here, there's a missing value, which is the factor A difficult, factor B medium. There's just a missing value, at least in my book. Now, maybe they meant it to be 0. In 2 by 2 factorials, you don't have to have the same sample size in each of the cells. It would be fine that there'd be a missing value there. But just as a strategy to go forward, I'm going to go ahead and put a period in there for missing. And again, we don't need the equal amount, but we'll just assume that's a missing data that we should have had. Right next to that, to the right of that, we also see 7Q in there. I just put a 7 in there. So our data won't turn out exactly the same as theirs, but it'll be pretty close. Okay, so when we look at this data, 2 by 2 factorial is called a means model. We're going to model each one of these cells in here. For example, factor A easy and factor B low. That's an individual cell we have here, and we're going to model that with the mean. And then we're going to get our errors based off the distance from the mean of that cell in this case versus the mean, for example, of the overall factor level. So and what we want to know is there a difference, for example, if you ignore factor B between easy and difficult? So if I just assume this was all one block right here and calculated the mean of that versus if we're looking at difficult and assume this is all one block, calculated the mean of this, that are these two means different in the alternative hypotheses? The null would be that the main effects, meaning the mean for easy versus the mean for difficult across the other factor is the same under the null. In the population, or is it different under the null? So really our question is the mean for easy versus difficult the main effects in the alternative? That's really our stated question. So let's go ahead and test that. Now to test that, we have to enter the data here, and the way we're going to enter it in SPSS is shown right underneath on the example. So what we had here is the subject, and I just put subject. This would be an individual person in the data set. So in the first set, in the first cell, where factor A was 1, factor B was 1, then these were the observations: 3, 1, 1, 6, 4. Now when I say factor A was 1, easy has been identified or coded as 1 here. And factor B, arousal level, low, has been coded as 1. So each factor will get its own column in SPSS. So factor A and factor B. Now we could have coded these 1s and 0s, or A and B, but it's just best to use numeric aspects. So we went ahead and put in all the data. Again, we had that problem here with number 22, that there was just seems to missing value there in the table because we have an N of 30. So I've just put in a period there, and that's an acceptable way in SPSS to code missing data, is just with a period. So, and then the 7 for across the other side. Okay, so now let's go ahead and enter this into SPSS. So I'm going to go over to SPSS and I'm going to look at my variable view first, and I'm going to name some things. So the first one I'm going to put subject, and that was just like if I had subject come in, I just give it a number, and then I had factor A. Now I can't have any spaces in the variable name, so I'm putting an underscore. Then I had factor B. And then I had the actual observation for that condition or that cell. Okay, so I've got those labeled in variable view. They're all numeric, which is just fine for us. And now I'm going to go ahead and click the tab over to data view. And then from the table, I'm just going to copy the data over. So I'm just going to grab the data, meaning I'm pressing my left mouse in the bottom cell, dragging it across, letting go, and then I'm going to go ahead and just copy it in. I'm going to start at the very top part, top row, top column, and paste that data in. And there we're in. And as you can see in SPSS, it's very important that, for example, here, this observation for subject 16 is a 0. That's different than a missing, which is subject 22. That's different. So it's very important distinction we're going to have in analysis. So once our data is in, we can go ahead and run this data. So we're going to test the main effects, and we're going to test the interaction as well. So I'm going to go up to Analyze, General Linear Model, Univariate. Okay, my dependent variable here is observations. This was the observed variable. My two fixed factors are factor A and factor B. Random's effects, as we've talked about a little bit before, if I would have had more factors, more levels of the factors or factors, and I took a random sample of those. But here we're specifically interested in learning about the actual factors, meaning the task difficulty and the arousal level. So those are called fixed effects. The covariate is something we make a statistical adjustment for. That, say, what if hand size had something to do with this? We might put it in there if it was correlated with the dependent variable, and we're uninterested in it, so it was just confounding us. That's what we're going to use the covariate for. But in this case, we need to do either. We don't need to do either one of those. We're just putting our two fixed factors in the analysis. Now, there's a couple things I want to do under the options here. One, I want to create a plot. Okay, so horizontal and separate lines. Depending on your preference of how you want to see the graph, it's which one you'll put. You can put, for example, factor A in the horizontal lines, or you could put it in the separate lines. It's up to you. But I'm going to go ahead and just put factor A into horizontal axes. And I'm going to put factor B. Let's see, factor A. No, the book did it the other way, so I'm going to go ahead and do it the other way. So I'm going to put factor B into horizontal axes and factor A into separate lines. Yep. And again, neither one's wrong. It's just how you want to look at it. Now, once I've bumped them both over, I need to click the Add button down here. So I'm going to click Add. Okay, and then I'll just go ahead and say Continue. Now, I also want to go to Options, and I want to get the means out, the descriptive statistics. So here's our options: the overall mean, the factor A means, the factor B means. These are marginal means, and then the interaction. So I'm just going to select all those. I just held down the Shift key, clicked through them. I'm going to bump them over and just ask for descriptive statistics. Okay, because in the reporting of this in a